Welcome back, ladies and gentlemen. In this video, we are going to continue our discussion on parameters, and specifically the goal of this video is to be able to eliminate a parameter, okay? So basically, when we do have some kind of curve that is defined parametrically, we're able to eliminate the parameter, so get rid of that quote-unquote new independent variable, t, which we've been using for the most part. So that's what we're going to see here in this example. We're going to eliminate the parameter and identify the graph of the parametric curve once it's been eliminated. So basically, let's put this into perspective. We are going to eliminate the parameter, aka we're going to eliminate t, and then kind of take a step back and then find what this curve is going to look like as a basic function, all right, a y equals function. So let's go ahead and first solve for t so that we can actually get rid of what t is going to look like in each of these. So I'm going to take my x equation, and then we're going to go ahead and solve for t. That way when we substitute it back into y, we're already set up and good to go with a y equals function. So let's go ahead and say we know that x equals 1 minus 2t. So therefore, we will solve for t by subtracting the 1 on both sides. And we'll go ahead and divide by -2. So t is going to ultimately be x divided by -2. So x over -2. I'm going to put the negative up top, kind of keep things a little bit nicer. And then -1 divided by -2 is a positive 1/2. And so that is the value of t in terms of x at this moment in time. And so now we can eliminate the parameter by now substituting that t new equation into y, because now it's going to be y in terms of x. And so now we can go ahead and see that y equals 2 minus our new equation. So we can go ahead and take a look here at just distributing that negative just to kind of clean things up a little bit. So we have 2 plus x over 2 and then minus 1/2. So we get y equals, and I'm just going to make this more into slope-intercept form, 1/2 x, and then the 2 minus the 1/2 will be 3/2. So that is kind of our new function, if you will, here. So that is the graph of our eliminated parameter. So of course, it's just going to be a line, and if we need to, we can go ahead and graph it. So just kind of real quick, when you are going back into your function mode, please make sure that you are now going to be doing a function. Look at how the y equals will be changing there. And then so for you, we had 0.5x plus 1.5, and we should see that there is our basic equation of a line. And it says for all values of t from -infinity to infinity. So if that's the case, we are kind of just keeping things as is. We're not bounding the parameter by any stretch of imagination there. Let's go ahead and do one more example in which we eliminate the parameter. So let's go ahead and take a look at a parameter here. I want to note here, just in case you get examples where they don't give you specific parametric intervals, the parameter doesn't have an interval, then we can kind of assume that it's for all real numbers, x and y. All right, so let's just go with that for right now, as long as we are not given any kind of information about the parameters intervals. So in this case, we have that x equals t squared minus 2 and that y equals 3t. So t can be any real number. So let's go ahead and solve the equation for t. It doesn't really matter which one you go for first, but I'm going to go ahead and solve for t using y just because it's a little bit easier to solve for t. So we get that t is going to equal y divided by 3. So that way when we substitute back into our equation, we can go ahead and represent it in terms of x or in terms of y. So we can go ahead and take a look here. So we have that x equals now y over 3 is t quantity squared minus 2. And so we get that x equals y squared over 9 minus 2. So, I mean, at this point, you've shown a horizontal facing, right, parabola. Right? That's basically what we've kind of shown in this case, right? So you can go ahead, however, though, and just solve for y and kind of re-go back and put this into a normal parabola. So right now, where we have this parabola going to be opening to the right. So if we interchange x and y, we can identify that this graph as the inverse of the graph of the parabola, which is x squared equals 9y plus 2. So let's go ahead and just kind of switch these guys around here. And we can see that we have y squared equals 9 times x plus 2. So at this point, you kind of see that I made two equations, obviously, right? So I solved for x and then I solved for y squared. You also notice that I didn't solve for y completely. I did not take the square root of both sides. Now just remember the reason why, because I don't want to restrict any of our domain for this case, or in this case, the range for y, but I don't want to restrict it because we're not given any information about the intervals, and so I just wanted to keep it for all real numbers like we assumed from the beginning. So what you will see in a lot of examples, though, it'll tell you which of the variables x or y that it wants you to solve for. But you just have to kind of be on the lookout as to which one they are talking about. So like if they would have maybe said, where we, keep all things positive for y, of course it could have square rooted both sides.